Alright, ladies and gentlemen, so in this brief video we're going to start looking into even and odd functions. Alright, quick definition of them, and then how do we actually determine if a function is going to be even or odd or not. And so when we classify a function itself to be an even considerable function, what that means is that it has symmetry about the y-axis. So if you think about a rotation about the y-axis, it is symmetrical on both sides of the y-axis specifically. One of the most common even functions is your basic parabola, f of x, or y equals x squared. That is an extremely simple and easy approach to identify if a function is going to be even or odd. And then what about an odd function? When we're dealing with odd functions, guys, I've always kind of used the adage as odd, think about O, because it is symmetric about the origin. So the O and the O match on up. And it gives us an idea that if we were to substitute a negative x on in, we'd get the complete opposite approach, opposite values in the function itself. The 1 over x function is an extremely common identifier of that as well too. And so what does it look like to be symmetrical about the origin? Well, let's say here is my graph that we're dealing with, and if you have the exact same thing symmetric about the origin like we do in an example like this, this would be considered an odd function. And so this is the graph f of x equals 1 over x. So how this makes this odd or symmetrical about the origin is because if I were to substitute f of negative x on in, I would get the complete opposite values in there. And it should represent also a 180-degree rotation if we kind of are making our geometrical relationships in there as well. So how can we actually physically determine if a function is even or odd, maybe before we're graphing anything? Well, it all is key into these two concepts right in here. If I were to substitute a negative x into the function itself, what do we get in return? So what ends up happening here, guys, is you're going to get one of two things, or one of three things, I guess, technically. You're going to get the exact same function, the complete opposite function, or just something random kind of in between. So let's take a look at this example here. If I want to determine if the function is even or odd, I'm going to replace x with negative x everywhere inside of that function. And it's going to allow me to see if I'm getting the complete opposite, if I'm getting the same thing, or a little something different. So let's take a look. So negative x to the 6th power, it's positive because it's an even degree. So x to the 6th. Negative x squared, well, that's just going to be negative x times negative x, so it's a positive in there as well too. So positive x squared times negative 2, you still have negative 2x squared and plus 3. So this completely matches with my original function that I have. And once it does that, this is a key factor that we have an even function that we are dealing with. And you can see the exact same method. It's going to come on out to be the complete opposite. So if everything was negative, it was negative x to the 6th, and positive 2x squared and negative 3, if all of those became the complete opposite in terms of their signs, then it would have been an odd function. All right? And of course, if there's something where it comes out where it's somewhere in between, then we're going to consider it's neither even nor is it odd. There's no symmetry over the y-axis or the origin for that manner as well. All right? All right, guys. That's our brief, quick analysis of even and odd functions. And we're on to the next one.